Hello and welcome back to the channel. This is CCNA course day 25 and I'm just going to speak about EIGRP configuration. In previous video I spoke about concepts of EIGRP, of course not in detail, but an overall concept was covered, and what I'm going to do here is I'm just going to speak about verification and troubleshooting of EIGRP network. So we are going to configure EIGRP, we are going to see who the participants are, we are going to see summarization and how we can configure summarization, which is important because summarization in EIGRP and RIP are very much similar to each other. And also we are going to verify and troubleshoot like a professional. So let's just start with the basics. The first thing that I'm going to do is to go to my lab. Here is the lab that we have configured before, but as you can see, this is the lab that we use for OSPF. So what I'm going to do is to remove this one, and the shape is going to go away, and this shape is going to kind of include all the routers in my network, and that's going to be an EIGRP region, and the region is going to have an AS number of, let's say, EIGRP, and autonomous system number could be anything. Let's say, for example, 1 or 100 or whatever number that you want to have in your network. So that is the overall configuration that we want to have in here. So let's start from removing the previous protocol that we had in here. So if I just go to one of these routers and say, for example, show IP protocol, this is going to tell me what protocol right now is in place, and you can see that I have OSPF1, and the other protocol, there's no other protocol which is here. I'm just going to remove OSPF from every router in here. So I'm just going to go to the commands window down here. I'm sending the commands to every router, and what I'm going to do is to say no router OSPF1, and with this OSPF is going to be removed from everyone in the network. You can see that the neighbors are down and we don't have any information about that. So right now if I say show IP route, you would see that or let's say do show IP route, actually you can see that do show IP route. You can see that all I have is the connected and local networks, nothing more than that. There is no routing protocol except one static route which is on router 6, which is here, and this is connected to the service provider up here. Okay, let's just start configuration from router 1. I'm just going to go to here, very much similar to OSPF. I'm just going to say router or EIGRP, and the next thing that you need to add to here is a name or a number. Most likely we are going to use a number because this is kind of old school configuration. But if you go with name, that's going to be okay. So we have two different types of EIGRP. One of them is named mode. One of them is numbered mode. We are not going to cover named mode for now, but right now I'm just going to say numbered mode is something that is easier to configure for most of us. But when we go to names mode, there are some stuff that we need to take into consideration. So I'm just going to go with number 1, which is the ACE number of the network. I hit enter, and the next thing that we have is a bunch of commands that some of them are very important. For example, one of them is going to say address family. In case, for example, you want to go with address family IPv4 or address family IPv6. Auto summary is important. By default, auto summary is disabled, fortunately. I always, of course, write no auto summary just to make sure that this is disabled, because on different platforms, maybe auto summary is enabled by default, but auto summary is disabled for the major networks in here. So when you say no auto summary, all the networks are going to be removed from auto summary. BFD, bidirectional forwarding detection, that is a very nice feature we are going to cover in maybe other courses for converging fast. Default information, we have used it in RIP, we have used it in OSPF, so you already know what default information is. Our default metric is something that we can configure in here, and distance by default is going to be 90 and 170, 90 for EIGRP internal, 170 for EIGRP external. Some important commands, neighbor, for example, in case you want to configure a neighbor using unicast and manually. Network, very much similar to network command in OSPF. Of course, we used interface configuration for OSPF, but network command was there. We are going to have the same thing here. The RIP was not another router, actually, routing protocol, which used network command. And variance, which we spoke about this in previous video. Another interesting thing is going to be shutdown, which is kind of a graceful shutdown feature that we have in EIGRP. The most important part is going to be no auto summary, which I'm going to put it here. And then I'm just going to start with the networks. Once again, network comes with the IP address or let's say network address and a wildcard mask. In my case, I'm going to say do show IP interface brief. You can see that I can just say network 0000 to include every interface in here, or I can just be very specific about the interfaces by going with 0000 wildcard mask in here. Which one is easier for you? That's up to your design. In here, I prefer to be very specific. So I'm just going to say network is going to be 10.131. 0000 is a wildcard mask, so I hit enter. The next one is going to be 10.121. And the next one is going to be 1111. So I'm just going to change this to 1111. Now I have done most of the configuration, which is a common part of the configuration. You don't really need more than this. So if I just go out of configuration mode and save the configuration, I'm going to say show IP protocol. Right now you see that EIGRP1 is part of here. The most important parts are going to be the metric weights. You can see that K1 and K3, which is going to be bandwidth and delay. These are configured with variance number of 1 with the same multiplier of 1. The rest of them, which is going to be reliability, let's say load and MTU, they are not used in the calculation. Also, you can see it says the distance is the default, 90 for internal, 170 for external. Maximum path is 4, which means that if you have up to 4 different paths with the same metric, we are going to use all of them in routing table. And maximum hop count is no longer 16, this is 100 here, which of course you are not going to go beyond this. And even in the biggest networks, you're going to barely going to go beyond 16 or something like that. But again, 100 is the limit in here, and these are the networks that we have for the configuration. Let's go to router 2 and start the configuration in here. So I'm just going to say router EIGRP, and the number here is very important. In OSPF, if you remember, the number was a process ID, and that was locally significant. Here, the number is for the region. So if you want to have adjacency with another router, you need to be in the same region with that. So I'm just going to say router EIGRP, right? Only one. Again, no auto summary. So that's it. I'm just going to say do show IP interface brief, because again, I want to be very specific. Network is 10.2.4.2.0.0.0.0, which means that the only thing that I want to match is this one. And then the other one is 10.1.2.2.1.2.2, 10.1.2.2. And the next one is going to be 2.2.2.2. So our network is going to be 2.2.2.2.0.0.0.0. And you can see that very fast we have a neighbor change. Here you can see that it says neighbor change, and this is of severity 5. Severity 5 means this is information for you. So dual has calculated and created an adjacency. You can see that we have a neighbor change in here. It says that the EIGRP neighbor is 10.1.2.1, which is the new adjacency. Now you can see that it says neighbor 10.1.2.1. It doesn't use the loopback interface as the router ID. It is using the interface which is adjacent with that and has participated in the let's say adjacency. There is a command here that says EIGRP, and after that you can see there is router ID. You can configure EIGRP router ID, of course, in here. And that could be again any number, but let's say, for example, in this case, I'm just going to say 2222, just to make sure that this is configured. On R1, I can do the same thing. So I can go to router EIGRP 1, and I can say EIGRP router ID is going to be 1111, and hit enter, and then this is going to be a little bit different. So right now, if I just say show IP EIGRP interfaces brief, This is going to, not brief of course, just without brief. This is going to show you the interfaces that we have for EIGRP right now, participating in adjacencies and stuff like that. I need to extend this window a little bit. You can see that there are two interfaces in here, and these are the interfaces that send and receive hello. So loopback interface is not part of this, although I believe that I have added loopback interface to the configuration. No, I haven't. You can see that there is a problem with that. So I'm just going to say configure terminal, rather EIGRP1. So you can see there is a misconfiguration. No, this one, but this one. 1, 1, 1, 1. Now, if I say show IP EIGRP interface, you can see that loopback interface is part of that. But you can see there are some important information. How many peers do we have? This means that how many neighbors do we have? On Ethernet 01, there is a neighbor. This is connected to R2 in here. And then you can see some more stuff in here. And that's it. The next thing that I want to show you is show IP EIGRP neighbor. Hit enter. This is going to tell me that there is a neighbor. This number in here, this is not important. This is just the order of, creating the adjacencies. That's it. Nothing more than that. But the most important part is SRTT is important, which means that round trip time for this specific segment is something like 10 milliseconds. And in your net, this is very slow link, of course. That is why you see this high amount of, let's say, latency in here. And also the sequence number is this one. And also this Q count is important. You should see that this Q count is 0 all the time. And the last thing that I want to show you is show IP EIGRP topology. I didn't enter. This is going to show me that all the routes are passive. This is important. If one of them is active, this means that you are trying to find a better path for that because the previous path has been lost due to neighbor changes. So in here you can see that there is one successor for now. The feasible distance is 281,600. You can see the numbers are very big. This one of course is not that big, but you can see super big numbers in here. And then it says that this is connected via Ethernet 00. And in here it says that, for example, 10.2.4.0 network is available through 10.1.2.2, which is router 2. And you can see that this is the reported distance. Oh, sorry, this is the feasible distance, which is, of course, mentioned in here as well. And the second number in here is the reported distance. And you can see that reported distance is smaller than feasible distance, or you would say feasible distance is greater than reported distance. And this is what you consider a feasible path, and you can see it in your routing table. And if I say show IP route, you can see that the EIGRP routes are marked with D, and that specific network 10.2.4, for example, is in here with this specific metric, which is the feasible distance, which is copied and pasted in here. Okay, I've configured router 2. Let's go to router 3 and do the configuration in here. So I'm just going to say router EIGRP1, no auto summary, and do show IP interfaces brief. And I'm going network are going to be 333.0.0.0.0. My network is going to be N133.0.0.0.0 and 10.1.4 and 5, of course. So 4 and 5. And you can see the adjacency with router 1 has been accomplished in here. Let's go to router 4 and do the same thing. First of all, saving this. So on here, show IP interfaces brief. Do show IP interfaces brief. Here we are. And router EIGRP1, no auto summary. And my network is going to be 10.2.4.4. And then that's going to be 10.3.4.4. And you can see the adjacencies coming up. And 10.4.5.4. 4.5.4. And finally we have network 5.4.4.4.4. And here we are. So this is the basic configuration that we have right now. Most of the time, of course, you will not need anything more than the basic configuration. Show IP interface as Brave. Here we are, and my router EIGRP1 with no auto summary is going to contain networks 10.5.6.5.0.0.0.0 and 10.3.5.5. Then we have 10.4.5.5. And finally, we have 5.5.5.5. Here we are, and then save the configuration. And finally, in router 6, if I say router EIGRP1, no auto summary. Once again, I'm pointing to the visual IP interface as brief. Okay, here we are. There is an interface connected to the internet, this one. I'm not going to advertise this into my route, but what I'm going to do is to advertise the static route that I have here. This is a little bit different from what you have in RIP and OSPF. You had something like default information originate, but in here I'm not using that command. I'm just redistributing this into my network. So first of all, I'm just going to say my networks are going to be 10.5.6.6. And also this is going to create the adjacency, as you can see. The other network is 6.6.6.6. And now what I'm going to do is to say redistribute static. And after that, you can configure a metric or you can configure a route map. I'm just going to go with the metric. And for metric, I'm not using a specific value. In some cases, and I'm just emphasizing here, in some cases, when the values are not important, you can just go with 1, 1, 1, 1, 1. You can see that the 1 with this space and another 1, you can see 5k values have been, specified in here. But if you want to be specific, so you're going to start with this. The first metric value is going to bandwidth. Let's say in my case, for example, that is 10 megabits per second. You should specify this in kilobits, so that's going to be 10,000. Kilobit per second, 10,000. That's it. The next thing that you want to have is delay. Let's say, for example, the delay is something like 1 millisecond per one. Then reliability is going to be the highest value. Then the effective bandwidth metric with 255 is going to be, this is a load actually. So I'm just going to say yes, 255 actually. No, that's going to be 1, the lowest possible value. And finally, we have the empty, that's going to be 1500. So these are the values that I am going to set for this and hit enter. Now, if I just go to other routers, let's say router 2, for example, and here I'm just going to just go for something like this. And let me say end. Save everything. And I'm just going to say show IP route of all the routers. You can see that I have the 0000 as an external router route in here with this specific, let's say, value for the distance. On every router, of course, you can see this one. So let me see if I can reach the different parts of the network. From router 1, I'm going to ping 6666. This is reachable. Ping 6666. If I source it from my loopback 0, is reachable. And if I try to reach to the internet, 8888, you can see that I have reachability to the internet. Interesting. Let's go back to here. So right now you can see that as I told you, auto summary is going to be optional because this is by default there, but I just wanted to make sure that this should be there. I have done this. When you configure a network, you can be very specific as I was, or you can be, let's say, very broad, like what you see in here. When we want to stop EIGRP on a specific interface, we have the passive interface command, very much similar to OSPF, which you had before, so I'm not going to include anyone in here. Passive means that no hellos is going to be sent out of this specific interface. For auto summarization and this contiguous network, so we have the old behavior, which is classful auto summary, but we can just type no auto summary, which is maybe for major networks, like I said, this is done by default. So that's it. And also we can have summarization. So what is summarization? Let's say I want to go to my topology in here, and let's say that on router 1, I have a bunch of loopback interfaces. Let's go to router 1. I'm going to say show IP interfaces brief. For now, I have only one loopback, which is loopback 1. I can add secondary IP addresses for that, or I can create extra loopback interfaces. That's up to you. On some platforms, you can have only one loopback interface, so you can already have multiple, but you can have multiple secondaries. The same thing, of course, here you can have multiple secondary IP addresses, but you can have multiple loopback interfaces as well. So I'm just going to say interface loopback, let's say 100, or let's say loopback 10, and then the IP address is going to be, say 10, 10, 1, 10. 110.11, and the mask is going to be 32 bits. I'm gonna go for 11, then something like 10, 10, 11, 10, 10, 10, 11, 1, or let's say yes, then 11. Then I'm going to have another one which is 10, 12. So I'm just going to go to 10, 12 here, and that's it. These three are going to be here. So right now, do show IP interface brief. I have this in here. I'm just going to go to router EIGRP1, and then I'm going to advertise in these into EIGRP. So I can say that network is going to be 10, 10, 1, 1. Again, I'm being very specific. 10, 11, 1, 1. And 10, 12, 1, 1. So this means that now what I have is all the networks are advertised. So if I just go to router 4, for example, and check my routing table once again, you should see that this 10 network is here. 10, 10, 1, 1 up to 10, 10, 12 more. But let's say that I just want to advertise a summary for this. Summarization is done based on the interface, so you should do it on the interface level. So first of all, you should decide what is the summary for this, and there are different ways to do that. For example, I know that the mask for, let me just open Notepad for you so that you can see this. Okay. So 10 is in binary is going to be something like this, 0, 0, 0, 0. All of them, of course, should be 0 like this. 0, 0, 0, 0, that is going to be 1, 2, 4, 8, so that's going to be 1, and then 0 and 1, 0. That is 10, right? So the value of this is 1, the value of this is 2, the value of this one is 4, the value of this one is 8, so that's it. Okay, the next one is going to be 0, 0, 0, 0, 1, 0, 1, 1, and finally the next one is going to be 0, 0, 0, 0, 1, 1, 0, 0. So that is what we have. So in here, I can just summarize up to here. You can see that there is up to here, all of them are same, but from here up to here, everything is different. So what I'm going to do is to go with slash, let's say 21. So that's it. So what is the value for here? That's going to be an 8, right? So the summary for this is going to be 10 is first octet. The second octet is one of these, which is going to be 8. As you can see, this is the value of 8, but the third, these remaining is not going to be used. So 0, 0. And the mask is going to be 2, 5, 5, 2. Here we have 5 bits. And just to simplify, this is going to be 1, this is going to be 2, this is going to be 4. So if you just add up, that's going to give you and 10, 7, that's going to give you a 248 here. Yeah, 0, 0. That is the summary that we want to have in here. I'm just going to copy this. I'm going to go to the interface level, R1. On R1, I'm just going to say interface range because I'm just going to advertise it on both interfaces. E00 to 1. Then I'm going to say IP summary address. And this is going to be for EIGRP. So I can go with EIGRP 1. And after that, this is the summary address that I have configured. You can go with slash translation or what I did in here. And then you can have a leaf map, but this is not going to be important for you. So I just sent it here. And you can see that there is a resynchronization after applying this summary address in here. Now if I just go to router 4 one more time and check IP route, this time you're going to see this one. None of the let's say addresses is present in here. If I just go up, you can see that previously we had 1010, 1011, and 1012, but you don't see them in here. Only the summary address is being placed. Great. So let's go back to here, and we just did the summarization, and we can configure it with make sense. Although we have the summary, we still have reachability. So if I just go to router 6, for example, and try to ping 10, let's say 1011, you can see reachability is still there, although we only have a summary address in here. And this is a stable, and we can scale it up. But of course, summarization poses some dangers, like, for example, loopholes, that you need to be very careful about that. Load balancing is available, and you can just do that. In my case, for example, let me see if I have anything that I can load balance. For example, on router 1, if I just go to my router 1 and say show IP route, you can see that I don't have any similar metrics, though some of the most of the paths are going to be via router 2, but you can see some of them are via router 3. If you want to have some more of these, you need to go with variance, but they should be available in topology table. So if I say show IP EIGRP topology table and see that you have only one of these as successor, so variance command is not going to make any sense in here. And then unequal cost load balancing, like I said, variance is going to be used for that. I have spoken about this before, so I'm not going to go to there. And finally, we have the verification commands. You saw show IP EIGRP neighbors, used it, IP EIGRP topology, show IP route EIGRP is going to show you only the EIGRP entries in routing table, and show IP protocol is going to show you what protocols are in use right now. And also show IP EIGRP interface, which we did in the beginning. You can go with detail, of course, after that, which is going to give you some more information. And also, when you say show IP protocol, you are going to see some information about the timers as well. I spoke about these, and I told you that Q count should be 0, SRCC should be the minimal amount of time, uptime shows you the stability, which means that how if it is higher, that's going to be better, and hold time, of course, means that what is the neighbor's health, and also some more information that I spoke about this. And what is in here, if I go to one of these routers, let's say again, once again, for example, router 1, and this only command that I haven't spoken about, show IP EIGRP traffic. It's going to give you some information about the hello messages, how many hello messages have been sent, how many have been received, how many updates have been sent and received, and then the queries, in case there is a query, for example, during the convergence is going to happen, and some more information that you can just take a look at in here and make sure that information are available for you. And the most common problems that you might see neighbor fails. One of them is going to be the interface down. If you just shut down an interface, it's going to happen. I told you that autonomous systems should be similar on the two interfaces being adjacent. K values should be the same on all routers. If you do not change the defaults, everything is going to be similar. We should have passive interfaces in case we don't want to create any adjacency. But if you want to have adjacency, if there is a configuration for passive interface, this is not going to work. Authentication, we have not checked it, but if you have mismatched authentication, this is not going to work. And also, there might be access control list blocking EIGRP traffic, which means that you can never really have any kind of EIGRP adjacencies. Okay, so in case you're missing some routes, you're going to take a look at what we have in here as a checklist. Are neighbors up? If they are up, then routes should be negotiated. Is the interface configured for EIGRP or not? Otherwise, this is not going to be inside our routing table. Is the network advertised or not? We configured networks for the interfaces of the routers which are going to participate in EIGRP adjacency, or we want to have their information like the loopback interfaces into EIGRP. Is summarization hiding it or not? Sometimes, for example, we are doing some summaries and you do not really see the actual route as you saw in my case. And is any AKL filtering or blocking the advertisement? So you need to be very careful about that. So we did this configuration and we did the verification, also troubleshooting tips that I gave you. I hope this has been informative for you. Thank you for watching. As usual, like, share, and subscribe to the channel, and drop your questions in the comments, and also hit that bell button so that you're going to be notified anytime there is a video uploaded. Have a good time and see you in later videos.